According to the National Electrical Code, which is the standard for electrical safety, there is no specific distance requirement between safety showers and electrical devices. However, the National Electrical Code requires that electrical equipment, including light switches and outlets, be located outside the prohibited zone around safety showers. The prohibited zone is defined as 3 feet or 0.9 meters horizontally, measured from the vertical axis of the safety shower head, and 6 feet or 1.8 meters vertically, measured from the spray nozzle of the safety shower head. The National Electrical Code requires that outlets within 6 feet or 1.8 meters of a water source be protected by a ground fault circuit interrupter, otherwise known as a GFCI. Safety showers are considered a water source, so outlets within 6 feet of a safety shower must be GFCI protected. Although the National Electrical Code does not specify a distance requirement, it is generally recommended to maintain a reasonable distance between safety showers and electrical devices to minimize the risk of electrical shock in the event of an accidental activation of the safety shower. A distance of 3 to 6 feet or 0.9 to 1.8 meters is typically considered acceptable. Outlets should be located in a position where they are not likely to be splashed with water from the safety shower. Lighting should be adequate to ensure clear visibility in the area around the safety shower. Electrical devices should be regularly inspected and maintained to ensure proper operation and prevent electrical hazards. Firstly, we need to understand the role of the National Electrical Code. It serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It's updated regularly to reflect new technologies and safety practices. The purpose of the NEC is to minimize electrical hazards, which can include electric shock, electrocution, fires, and explosions. It sets standards for wiring, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is often legally mandated, meaning adherence is not just a matter of best practice but also a legal requirement. Secondly, consider the prohibited zone around safety showers. The NEC does not explicitly state a required distance, but it does define a prohibited zone. Within this zone, electrical installation should be minimized or specifically designed for wet locations. The horizontal distance of 3 feet or 0.9 meters from the shower's vertical axis is intended to prevent accidental contact with electrical devices while someone is using the shower. The vertical distance of 6 feet or 1.8 meters extends upward from the spray nozzle to account for the height of the water spray, further mitigating risk of electrical contact. Thirdly, we'll delve into ground fault circuit interrupters. GFCIs are crucial safety devices that protect against electrical shock. They work by monitoring the current flowing to and from an appliance or outlet. If there's an imbalance, indicating current leakage to ground, the GFCI quickly cuts off power to prevent injury. The NEC mandates GFCI protection in areas where electrical equipment is likely to come into contact with water, which includes locations near safety showers. Fourthly, let's discuss best practice recommendations. While the NEC provides a framework, adhering to additional safety recommendations can further reduce risks. This can include locating electrical panels and outlets further away from safety showers than the minimum requirements, using splash-proof covers on outlets and switches, and conducting regular safety audits to identify and address potential hazards. Fifthly, consider specific equipment and installations. When installing or inspecting electrical equipment near safety showers, you'll want to ensure all components are rated for the environment, meaning they are resistant to moisture and corrosion. Wiring should be properly insulated and protected from physical damage. Lighting fixtures should be suitable for wet locations and positioned to provide adequate illumination without creating glare or shadows. Sixthly is regular maintenance and inspections. Electrical equipment should be inspected regularly for signs of damage, wear, or corrosion. Any issues should be addressed promptly by a qualified electrician. Ground fault circuits interrupters should be tested monthly to ensure they are functioning properly. Keep records of all inspections and maintenance activities. Seventhly, we need to think about training and awareness. Laboratory personnel should be trained on the proper use of safety showers and the potential electrical hazards in the area. Post clear warning signs indicating the location of safety showers and electrical equipment. Encourage a culture of safety where everyone feels empowered to report potential hazards. Eighthly, we can evaluate the use of alternative solutions. Consider alternative solutions to minimize electrical hazards near safety showers. This could include using wireless switches, battery-powered devices, or non-electrical alternatives whenever possible. Explore options for relocating electrical equipment to a safer location away from the immediate vicinity of the safety shower. Ninthly, let's delve deeper into the National Electrical Code. The National Fire Protection Association develops and publishes the National Electrical Code, and it's updated every 3 years to incorporate changes in technology and safety practices. It is widely adopted in the United States, and compliance is often mandated by state and local regulations. Understanding the relevant articles and sections of the NEC is essential for ensuring electrical safety near safety showers. Tenthly is on risk assessment. Conduct a thorough risk assessment to identify potential electrical hazards associated with safety showers. Consider the likelihood of accidental activation, the presence of flammable materials, and the potential for electrical shock. Use the risk assessment to prioritize safety measures and allocate resources effectively. 11thly, we should consider the types of safety showers. Safety showers are designed to provide immediate flushing of hazardous materials from the body. There are several types, including deluge showers, which provide a high volume of water over the entire body. Eye wash stations are designed for flushing contaminants from the eyes. Combination units include both a shower and an eye wash station. 12thly, let's discuss grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse. Bonding connects all metallic parts of the electrical system to create a low impedance path for fault current. 13thly, we will consider the use of personal protective equipment. While not a substitute for engineering controls, personal protective equipment can provide an additional layer of protection. Laboratory personnel should wear appropriate personal protective equipment, such as insulated gloves and safety glasses, when working near electrical equipment. 14thly, consider the location of electrical panels. Electrical panels should be located in a dry, easily accessible area away from safety showers. The panel should be clearly labeled and protected from physical damage. Keep the area around the panel clear of obstructions to allow for easy access in case of an emergency. 15thly, we will explore lighting considerations. Adequate lighting is essential for ensuring visibility around safety showers. Use lighting fixtures that are rated for wet locations and provide sufficient illumination without creating glare or shadows. Consider using emergency lighting to ensure visibility in the event of a power outage. 16thly is about the use of signage and labels. Clearly label all electrical equipment, including outlets, switches, and panels. Use warning signs to indicate the presence of safety showers and potential electrical hazards. Use multilingual signs to accommodate personnel who may not speak English. 17thly, we can think about documentation and record keeping. Maintain detailed records of all electrical installations, inspections, and maintenance activities. Keep copies of relevant codes and standards, such as the National Electrical Code. Use documentation to track trends and identify potential problems before they become serious hazards. 18thly, it is on emergency procedures. Develop and implement emergency procedures for dealing with electrical accidents. Train personnel on how to respond to electrical shocks, fires, and other emergencies. Post emergency contact information in a prominent location. 19thly, we have to address contractor safety. Ensure that all contractors working on electrical systems are qualified and licensed. Verify that contractors are familiar with the National Electrical Code and other relevant safety standards. Supervise contractor work to ensure that it is performed safely and in accordance with applicable regulations. 20thly, we'll evaluate continuous improvement. Continuously evaluate safety practices and procedures to identify areas for improvement. Solicit feedback from laboratory personnel and other stakeholders. Implement changes based on the evaluation findings. Lastly, we need to stay updated with the latest codes and standards. Electrical codes and standards are constantly evolving. Stay updated with the latest changes and revisions to ensure compliance and maintain a safe working environment. Subscribe to industry publications and attend training courses to stay informed. Ultimately, it's all about understanding the code, understanding the physics, understanding the implications.